Hello friends, I am Benedict George. This is video number 2 for errors in the Lorentz transformation. So in this video, I will specifically talk about the error in the derivation of Lorentz transformation. So Lorentz transformation, the equations are there. Those equations are base of special general theory of relativity and quantum mechanics. So if base is wrong, then the results of the theories which are based on these equations should also be wrong. So let us go through that. So first, I'll just revise whatever I have given in my last video. So what I have given in last video is this x minus vt of Galilean transformation is not equal to x rest. This I have proved in last video. Let us see in this in short. So the equation of Galilean transformation is given by this. This equation is used in Lorentz transformation. So once this equation is wrong in Galilean transformation, then this equation is also wrong in Lorentz transformation. Okay. So let us see x. What is x? When we check x, when we throw a probe from stationary frame of reference to the moving frame of reference, we need to find the position of p. But position of p has transformed to p dash in the moving frame of reference. So when we send a probe to find the position of p, we will actually find the position of p prime, right? So that will be included in value of x. So what is x? X is o prime p, and p prime. So we'll write down o p prime plus p prime. Oh, I'm making some mistake. O prime plus p o prime p plus p prime, right? Then vt is equal to minus o prime. We cancel this. What we get is o prime p plus p prime, right? What is o prime p? O prime p is equal to x rest, is x rest plus p prime. See, x rest is not equal to x minus vt because p prime is also there. Therefore, I have proved that x minus vt is not equal to x rest, right? But the main issue with this is we have to find a transformation of a point P which is at rest. This is transformation of point P which is at rest, and we have to find this transformation from P to P prime. So how we have to do? You have to take x rest, you multiply with transformation factor, you get x prime. That is transformation of P to P prime. That is O prime P prime. So once this is not x minus vt is not equal to x, not equal to x rest, therefore this equation is wrong. Thus even this equation given by Galileo is also wrong, right? Now this we will use it when we go to derivation, actual derivation of Lorentz transformation. So here comes the derivation. This derivation I have verified from many books, even through net I have verified, and The main source of this derivation is given by Mr. Peter Fisher. He is an ex professor of MIT, and this is a link. I'll provide you the link in description box. So this is a derivation, right? Now in this derivation, I'll go part by part. First I'll show where are the errors. Then I'll go part by part because it is very big derivation, so I cannot do it on one slide, so I have to take part by part. So let us see first this part, second part, third part. Right now, this in first part, the problem will be in this. When they assume this x is equal to vt and x prime is equal to 0. When they assume this, there is error. What is the error? I'll let you know. Then this is the error because of this. This is the second error, right? Third error is assumption that there is time dilation. There is no time dilation, so error is here. When this error is there, because of this error comes in this, because this is actually this, right? Once error comes in this error comes in this, and then if there is error in this part, then the equation itself becomes wrong. So at three places the error is there. One is this, another one is considering that x minus vt is equal to x minus vt is equal to x. Actually it is x prime, but they are thinking it is x rest, right? And then they are treating time in this frame of reference as time dilation, that is time has increased, but there is no increase in time, okay, as compared to this. So there is error, and then when you calculate value of alpha, that is gamma, actually a, that is gamma, then value of gamma is wrong, and if value of gamma is wrong, x minus vt is wrong, whole equation is wrong, total equation is wrong, right? Let us see part by part. First part, see here, they have taken a basic x prime is equal to x minus vt. This is from the Galilean transformation they have taken. Now what they have assumed is that x is a function of some a and t is a function of b, right? It is right, you can assume this way, right? So x prime is function of a and b. Now they have used their values to find value of a and b. This a and b, they have used some values, right? So these values, they put values in this equation and try to find the value of a and b, right? So x is equal to vt. Now what they have done is they have taken x is equal to vt. It is for the condition where this one event, an event happens at the O prime, that is the origin of moving frame of reference. When there is event is happening, that event is registered by observer in stationary frame of reference. Because it happens at the origin, x, value of x will be O prime. That is x prime is equal to 0, because this is the point is at the origin. So x prime is equal to 0. So they have taken x prime is equal to 0. That is 100% correct, right? So but vt, x is equal to vt, x is equal to vt, this value they have taken, and that is wrong. They have taken, why? Because it is moving, this frame of reference is moving with velocity v, and we have seen earlier that the if this equation is correct, then there is a transformation of point P to point P prime. Once there is a transformation, then what happens is this O prime move to O1 prime. So this value of Vt will not remain Vt. It will become this gamma Vt. It has transformed from here to here. So their assumption that x is equal to Vt is wrong. X prime is equal to 0 is right. This is what. So what should be the right assumption? Here, right assumption should be x is equal to some gamma Vt. But gamma is described later on. We got the value of gamma later on. So gamma can be any other function. Say c, they have taken this ABC. So there can be a function c. X is equal to function c Vt. C we will not take because you're taking the velocity of light. So R we can take. X is equal to R Vt. This is your, this should have been here. So error is here. Now you understood error is here. Right? Now this error, if we consider, chalo, this is right. Okay, they have taken right. This assumption is right. Now in what circumstances this x minus Vt is actually equal to x minus Vt, not x is equal to gamma Vt. Right? So in what circumstances? So let us see here. X is equal to when? X is equal to Vt is when this is stationary, there is no transformation. Right? So once it moves from here to here and stops, then this O prime will not transform to this, it will remain here. So when the probe goes, when there is one event happens here, it will register in this frame of reference and this length will be Vt. So x is equal to Vt. It will be right because there is no transformation for a stationary frame of reference once it is stopped, and x prime is equal to 0. Then this assumption on. That means if this is stationary frame of reference, then only the whole equation can be true. So they have derived this equation for stationary frame of reference. This is not a relative frame of reference. You can check it out, you can verify. So once this is stationary frame of reference, this equation will always remain true for stationary frame of reference, not for relative frame of reference. So if you use this equation for a moving frame or relative frame of reference, then the error will crept in. So what will be the error? When this frame of reference is stationary, the error is 0. Stationary then error, no error. If this is stationary, S prime frame of reference is stationary, there is no error. But if it is moving with velocity v, then error will start increasing. And if it reaches to the highest velocity, that is c, what they are proposed, nothing can go beyond c. Though I digress from it, but still, if you take the maximum velocity, the stationary velocity, velocity of s prime is equal to velocity of s prime is equal to c, maximum velocity, then error is equal to infinity. So this much error is there in this equation, as the moving frame of reference increases its velocity from 0 to c. So this is wrong. This assumption is wrong. Now next, this part they have got it through the using this equation. Again, this part is wrong, because I've already proved that x minus vt is not equal to x rest, and this equation actually should contain x rest, not x minus vt, because this x has problem, because it's already transformed, right? So here is the second issue. Now next, third, this is the most important error, and you have to visualize a lot. Kindly visualize as I visualize, then you compare with what they have visualized. So let us see what they have visualized. So they have visualized is that there is a frame of reference, stationary frame of reference, which is stationary, and there is another frame of reference, this one coming from behind, and when this coincide, this origin coincide, there is a flashlight in moving frame of reference. There is a flash, some event happening, and it is checked by this, registered by this observer in this frame, stationary frame of reference, and it moves away. It is like going like this. It is not stopping, it is going with the uniform velocity, right? When the flashlight, when there is an event or light flashes, it reaches the point P in frame, point P in the moving frame of reference. Actually, it is not point P, it is point P, and there is a mirror. Again, there is a that flash will be reflected back to the stationary frame of reference. That is, observer will again register that thing, and the observer will register the time taken from this frame of reference to point P prime, right? So there is light going, and it will again come back. So the distance will be this distance, and this distance light will take. So double the distance, it will divide the distance by 2, and you get the distance from here to here, right? This is what they have assumed. But in reality, what happens? In reality, what happens is that if you go by this equation, there is a transformation. If transformation of point P is there to point P prime, then there is a transformation of origin also. That means origin O prime will move to O1 prime. So there can be two conditions. One condition is that this is the frame of reference, right? Stationary frame of reference, and it is moving like this with a velocity v. This is moving frame of reference with velocity v. When it comes here, what happened? This person, there is an event. This person sitting, observer sitting in the stationary frame of reference, when it reaches here, actually there is a flash, and because it is transformed, so it has come here, right? And then moves. So actually it was here, but this fellow finds it here and moves away, right? So the time taken will be the same. Let us see if we go here, second part, if it goes here, and when it comes here, actually he finds it is the frame of reference is here theoretically, but actually it has transformed from here to here because of the velocity, because of this equation. So it has already transformed. So the observer is thinking it is simultaneous, but no, it has already transformed here. So the time will be from here to here, it has transformed to here. So see the time this and time taken by this, because the velocity of light is same, in both frame of reference, what will happen? Equal amount of time is taken in both the frame of reference. When equal amount of time is taken both the frame of reference, then there is no time dilation in moving frame of reference. When there is no time or dilation in moving frame of reference, that means t registered by this and t in this will be same. Right? So there may be someone, they have also marked a point P here. So they will check, sorry, P here. So they will check the timing and they will check the timing here. Because it has moved, the time is also same. So this time and this time will remain same. So there is no time dilation. So t is equal to t prime. So this is also wrong assumption. So that is x. If you put these values in equation 5 and 5b, this equation 5 and 5b in equation 3, then c t is equal to a ct minus bt. Both are same. And ct is equal to a ct plus vt. Right? See here, both are unequal, they are not equal. That means again these assumptions are wrong, and when this is wrong, so whole derivation goes wrong for here, right? And when they find the value of a, then value of a also is defective, wrong. And when the value of a is wrong, that means gamma is wrong. When gamma is wrong, whole equation is wrong. I've already proved kx minus vt is wrong, and I proved gamma is also wrong. That means the forward transformation equation of Lorentz transformation is wrong. It is wrongly derived. Right? In another video, I'll show you this derivation of reverse transformation is also wrong. I'll show you with the graph, these graphs. So, friends, I have shown you the errors in derivation of Lorentz transformation. Kindly analyze it, criticize it, give your suggestions. I'll be happy with everything. All your comments, kindly put your comments. This is my email ID. You can send me your comments through my email ID also. And share it if you find I am right, then share it with your teachers, with your professors, those who are very good in relativity. And if you give me a chance, if you give me your suggestion, proper suggestion, then I'll transform the whole theory of general relativity. There are a lot of problems are there in the theory of general relativity, as I have already gone through all. I have sent these research papers to many universities, professors of universities. There, I haven't received any information from them. There is nothing I have received from them. So maybe they are busy, or they don't consider me of that level. I can do something. So kindly share it so that they can also receive this. These are my references. I already showed you the references. These are my references. Thank you so much for listening to me.